Hello, and welcome to another chemistry video with Mr. S. Today we're going to continue with organic chemistry, looking at alcohols, which is the homologous series containing the functional group OH. Here you have the general formula, and here we have a very simple alcohol called ethanol. Now, why is it called ethanol? Because there's two carbon groups, carbon atoms, and the OH functional group. Remember that the name starts with ethan, indicating two carbons, and ends in ol, meaning that there is an alcohol group. Now I've put another ethanol next to it just to talk about the hydrogen bonding that exists between molecules of alcohols. Because oxygen is a lot more electronegative than hydrogen, it attracts the electrons in the covalent bond more towards it. So it has a partial negative charge, leaving hydrogen with a partial positive charge. Now, that's the same with the ethanol next to it. So if you have a look at it, there must be an attraction between the oxygen atom on one molecule to the hydrogen atom of another. This attraction is called hydrogen bonding. It's the strongest type of intermolecular force. That is why alcohols have a high boiling point compared to other organic compounds. Now, what kind of reactions do alcohols undergo? The most common reaction you're going to see is called oxidation. Now, ethanol can be oxidized to an aldehyde. Now, what do you need to do to make that happen? You need to use an oxidizing agent, which usually is a dichromate ion, so sodium dichromate, for example. To make that easier in equations, sometimes we summarize it with the brackets and O, indicating an oxidizing agent. And we need to heat this up. We need to have sulfuric acid as a catalyst. And we need to use a process called distillation if we want only to make the aldehyde, which is this group here. Watch future videos about this functional group. Now, to know if this reaction has taken place, you will see a change in color of the dichromate because dichromate is being reduced as it oxidizes the alcohol. So we're going to see a change in color of the dichromate from orange to green. Now, if you want to go all the way to the carboxylic acid, so ethanoic acid, which is the diagram here on the bottom right, instead of using distillation, you can just use reflux. And that's when you have the condensation tube, the condenser, vertical and not slanted horizontally, which is distillation. And we go directly to the carboxylic acid. Now, we can only transform or convert an alcohol to an aldehyde and a carboxylic acid if it is a primary alcohol, which means that the OH group is on a carbon that is bonded to no other or one other carbon. So this one here. This carbon is only bonded to one other carbon. And therefore, it can bond more, enough double bond to oxygen, or it can even form a carboxylic acid. If we have a secondary alcohol, where the OH group is on a carbon that is bonded to two carbons, neighboring carbons, that is called a secondary alcohol. And if we do this oxidation reaction, we only make a ketone. Okay, which here we've got propanone, 3 carbons, propanone. Now, if you've got a tertiary carbon alcohol, then you cannot oxidize because carbon is already bonded to 3 other carbons. It cannot form a double bond with oxygen. Those are the reactions of alcohols. Thank you very much for listening.